Welcome to the Renewable Energy Study Group. In the today's session, we're going to talk about the points regarding the characteristics of the solar cell. As we know, the solar cell is a main element in the solar panel actually. By constructing the solar cells in the number of series combination, we were preparing one solar module. So basically, while preparing a solar module or selecting a solar module for power plant installation, it is very much important to focus on the characteristics of the solar cell actually. There are several characteristics there, or the several parameters are there on which we were selecting the solar cell. Out of first is the short circuit current of the solar cell, which is also denoted by the IOC. The maximum current that a solar cell can deliver without harming its own construction, it is measured by the short circuiting the terminals of the cell at most optimized condition of the cell for producing the maximum output. Basically, the short circuit current is a maximum current produced by a solar cell when we are shorting the two terminals of the bus bars at this point. That time we can say whatever the maximum current we are getting cell wise, that is a short circuit current is for the particular solar cell. Then there is a second point, we call it as open circuit voltage of a solar cell. So basically it is a no load condition. Whenever there is a no load is been applied to a solar cell, what a voltage has been generated inside a solar cell connected through a bus bar, it is called as the open circuit voltage of a solar cell. There is another point, we call it as a maximum power point of the solar cell. Maximum power point means is a multiplication of the maximum voltage that we are getting and maximum current that we are getting from individual solar cell. So basically when we are attaching a solar panel or a solar cell with a NPPT tracker, that is a maximum power point tracking algorithm, what maximum amount of the particular voltage and the current that we can draw from a solar cell, and this multiplication is nothing but the maximum power that we can get from a solar cell over here. Basically when we see on the IV curve, so basically the maximum current is the short circuit current denoted in the y-axis and the open circuit voltage denoted on the x-axis. So basically as per this particular working of the, when we are joining the short circuit current and open circuit voltage, so here what we have drawn this curve over here. So basically at this bending point over here, we are getting the maximum power that solar cell could have been generated actually. So when we just project this particular point over this y-axis on this IM, we are getting this maximum current. On the x-axis, we are getting the maximum voltage over here. Then another parameter in the solar cell, we call it as a fill factor. Fill factor of the solar cell is nothing but it is an numerator and denominator parameter, or the ratio we are taking over here, that is a maximum voltage multiplied by the maximum current divided by the open circuit voltage multiplied by the short circuit current over here. So let's say the 370 wattage of a solar panel for a Tata Solar Power actually, we are taking the parameters of this to calculate the fill factor for the solar cell. So for the particular solar panel actually, we are getting the maximum voltage of 39.30 and maximum current of 9.42. Short circuit current of 9.80 and open circuit voltage of 48.08. Just by doing this calculation, we are getting the answer of 0.78. We just multiply by 100, we are getting 78% is the fill factor for the solar cell, that which we were considering for the installation of a solar project. Then there is another parameter, we call it as an efficiency of the solar cell actually. Efficiency parameter is nothing but what maximum power that we can get from the solar cell divided by, according to the area, we multiply by 100 over here, that is a input power that we are giving by with the help of a solar radiation. Whatever the value that is coming, it is nothing but the efficiency over here. So let's say in this calculation over here actually, we have taken this maximum power getting from the solar cell divided by the input power that we are giving to the particular solar panel over here. So to calculate the efficiency of this particular panel actually, we just keep over here PM divided by 1000 multiplied by A, where capital A is nothing but the area of the solar cell or area of a solar panel for which we are calculating the efficiency over here, and multiply by 100, we are getting the answer of it. So we are taking this parameter PM is equals to 39.30 multiplied by 9.42 divided by 1000 multiplied by the area of a solar panel, that is the length is 1.96 and height is up to, or the width is up to 0.99 over here in terms of the meter. Just by doing this calculation over here, we can easily get this efficiency parameter as 19.07 percentage over here. Then when we talk about the effect of the different parameters on the PV cell over here, there are basically two main parameters that are affecting the performance of the PV cell over here. Out of the first parameter is the temperature effect over here. As good as temperature of a solar panel is increasing, simultaneously the output from the solar panel that we are getting is decreasing over here. So when we majorly focus over this curve, actually we came to know at a point of 25 degree over here, we are getting the maximum power output of 50.2 wattage, and the operating cell temperature of 40 degree, we are getting the output of 46.5 watt. Operating cell temperature of 55 degree, we are getting the maximum power is at 42.9 wattage, and for operating temperature of 70 degree, we are getting 39.3 wattage over here. So when we talk about the effect of the light intensity on the solar PV cell, actually as good as the intensity of a solar radiation is increasing, simultaneously the output that we are getting from the solar panel is also increasing over here. Actually, let's say the solar irradiation which is falling as 1000 watt per meter square or 1 watt per centimeter square, at this particular situation we are getting the maximum voltage also, and we are getting the maximum current also over here. That is why it is very important how much amount of intensity of solar radiation is falling over a solar panel, because it is a main decisive factor over here. The current which is generated inside the solar panel is directly proportional to the intensity of a light in terms of watt per meter square, and the voltage in a solar panel is logarithmically proportional to the light intensity over here.